Okay, now let's solve a problem on root locus. Let's say the g into h is given as follows. Okay, g of s into the h of s is equal to k divided by, this is s into s plus 1.5 s plus 3.25 into, this is s plus 9.85. So plot the root locus for the g into h equal to this. Right. Now the initial steps are like this. We always make note of the number of poles and the number of zeros, and from that we decide how many of the branches will be there and how many branches will go to infinity. This is the first information that we are going to gather. Okay, so first, right, so this is the p for the number of poles. That's the terms in the denominator, or roots of the denominator. We have four, correct? Four different terms we can see. So number of zeros, it's similar terms in the numerator. After k, whatever you have, if you have s minus something, s plus something, then yes, right? So number of zeros equal to 0 here, no zeros. Okay, now the number of branches going to infinity. How many branches will go to infinity? Do you remember how to identify that? Or first of all, how many branches will be there? That's the first question. No, no need to apply. Formula is there, yes, correct. But from the basics, if you remember, there is one point which says that any branch will start from a pole and it will end at a zero. Okay, so if there is no finite zero, then a branch will go to infinity. Fine. So according to that, how many branches should be there now? Not going to infinity. There has to be four branches. That's the first thing we come to know, because that is how many poles you have, so many branches will be there. Okay, so there are four. This is corresponding to the number of branches, right? So n is equal to, I'll write n is equal to the number of poles minus number of zeros. That is equal to, in this case, that is also 4. This is the number of branches going to infinity, right? Because if there were two zeros, two of those branches will be terminated, right, on the graph, correct? They are not going to infinity. That's why the remaining two will go, right? If at all z is equal to 2, so 4 minus 2 is 2 branches will go to infinity. That's what we used to write. Okay, but in this case, p minus z, right, is equal to this. Okay, so what are the locations of zeros, right? So zeros are located at, not zero, sorry, it's a pole, right? Because we don't have a zero. Wait, I'll just correct. Zeros located at, yes, sorry, once again I wrote 0. It's pole, my mistake. Just poles are located. Yes, equal to. So what are the locations of poles? Set s equal to 0, minus 1.5, correct, minus 9.85. right? So we can start drawing the root locus right away because you know that, right, the location of the poles, and immediately we can start. Okay, so considering that, okay, we'll mark the poles now. This is at 0, this is minus 1.5, correct, correct. So that's the first thing when we start drawing the graph. Now we have to consider that uh, we are using that rule to identify which part of the real axis root locus is going to exist, right? Right, so that we'll see. So it says that you consider any point on the real axis if the total number of poles and zeros to the right side of that point is an odd number, then there is root locus, right, at that point. Right, let's consider. So I am considering this side now. This is a real axis. So any point you consider, to the right side you see how many poles or zeros you have, the sum of poles and zeros. Okay, and as of now I see that it's 0, it's a even number, so there is no root locus, right? I move slightly to the left, so this is true until I reach this point, correct? So once I cross this point and I come to the left, I check now. So how many poles or zeros are there? There is one pole on the right. You start from here, you come till here, and you until you reach the 1.5. This is the case. So every point between 0 and minus 1.5, yes, root locus exists, right? So what we do, we draw the root locus between minus 1.5 and 0. Root locus on this part of the real axis, yes, there exists. Once again, if you move between minus 1.5 to minus 3.5, on the right side, the total number of poles and zeros, the sum is equal to 2, which is even number. Okay, there are two. Yes. Towards the right side of that region, you consider all together total number of poles and zeros together. Okay, so you consider. Now I see that it is an even number, so there is no root locus here. Right. Once again, you come between these two, and you can check that the number of poles or and zeros to the right side of this, the sum is odd number. So yes, there is root locus between this. Okay, yes, so that's the first important rule we are going to apply always. Okay, yes, this is done. Right, so that rule is applied to this. After this, now you check after this till infinity to minus infinity, you check always any point you consider, right? What's the number of total number? It's a even number, right? It's 4. It is 4. So no root locus on the real axis starting from minus 9.85 till infinity, till minus infinity. Okay, that's the thing which we understand. Okay, so no root locus here. So this actually goes to infinity. This is the real axis. This is the imaginary axis. Huh. Root locus exists on the real axis if the number of poles and zeros, if the sum of poles and zeros to the right side is an odd number. Okay, or to the right side of a given point you can consider, because I'm checking that whether that at that point do you have root locus or not. Yes, is it or not? Right. Once this is done, so things become more clear now. Right. We know that the what do you call branches. Now, we discussed just now. We have written the number of branches. There are four branches. Yes. Right. As of now, we don't see four branches. Right. Yeah. So, but it's obvious that I can mark the branches directly now, because every branch is going to start from a pole. Wherever I see a pole, yes, there is a branch. This means this is a branch. This is a branch. Okay. This is the other branch. This is a branch, and this is another branch. Okay. So it's clear now. So there are four branches, but yes, correct, correct. That's right. Yeah. So always a branch starts from pole, and it is intended to go to a zero. And since there are no finite zeros on this graph, all the four branches should go to infinity. Correct? Okay. Now, which means somewhere in the middle, right? When two branches come towards each other, somewhere in the middle, right? Maybe here, they break away and they go to infinity. Okay, this is the next point. I have to identify where is the breakaway point. Okay, right. I need to identify breakaway point, but we'll come to the breakaway point slightly later, because there is another point to understand. Right. Another important note about the root locus is that whatever you plot on the upper side of the x-axis should be right repeated. It's a mirror image, symmetric about x-axis. Can you tell me why? What's the reason? You can just guess that. It's there is nothing. It's not a very complicated this thing. Easily you can guess why. Correct. So when other than the real roots, right, you always get complex conjugate roots. Correct. So for any root which is present below the x-axis, you have a conjugate root on the other side, right? That's why it is symmetric. Okay. Now that means if I draw, for example, there is a branch going like this, means I have to draw like this. Correct. To go to infinity. But now how many solutions you have, how many ways you can make those branches to go to infinity, how many options you have? Can you write like this? Yes, we can write this is also going to infinity. Can I write perpendicular? Yes, definitely. Second answer, third answer. Or actually you have infinite solutions here. Out of those infinite solutions, which one to select? Which is there could be only one answer actually, right? I should not have infinite solutions with me. I can have only one. So for that, what we are going to do now is, right, we'll take a help of some special straight lines. They are called as asymptotes. Correct. So asymptotes, if we look at the definition of asymptotes always with respect to some curve. When I say there is an asymptote, this is always with respect to some curve. If you have a simple straight line, we cannot call it as a asymptote. Okay. Now, the curve which we are referring now is, sorry, are the branches, they are coming from the root locus, right? There is another set of, there is another set. You see, here also you have a breakaway, correct? Again, right, I may have a branch going to the right, go to the left, or uh, making 90 degrees, right? Which one I have to choose, right? For that reason, again, I need asymptotes. So I'm expecting there are four branches, so I'm expecting four asymptotes. Again, coming back to the definition of asymptotes, asymptotes with respect to any curve are the straight lines which which take that curve to infinity, right? And they meet at those curves at infinity, right? In a sense, they are parallel. they are never going to meet, right? So using asymptotes, we can put restriction on any curve, right? To we can put a restriction to lie within a region, within a specified region. You can restrict. Okay, I'll show you that in a while. Okay, fine. So now, in order to draw the asymptotes, again, straight lines cannot be drawn at random. Now we have to be very specific. For that reason, what we do, we go for the, we have to identify, first thing is one point on this real axis where all the asymptotes meet. It is called as a centroid, right? So first idea is to calculate the centroid. Okay, and then we'll find out the angles made by different straight line or asymptotes with respect to x-axis. So our intention is to do that now. So we'll calculate, we'll come back and we'll draw, we'll continue the graph. Okay, now so let's go to the concept of asymptotes. Right, first you need to calculate the centroid. So centroid is a point on the graph where all the asymptotes will come and meet. Okay, so this is equal to, normally this is the equation, the summation of poles minus summation of zeros whole divided by the number of poles minus number of zeros. Okay, so I can see that the poles are located, first one at 0, and second one, we'll write the exact location, 1.5 minus 3.25 and minus 9.85, correct? Minus, there are no zeros, so you don't have to write anything, whole divided by p minus z is 4. Yeah, sure, please take your time. Okay, this is minus 3.6y is the location of the centroid. Okay, we can mark it as a C point, and we'll come back to the graph and we'll mark the C now. So this comes to be minus 3.65. Okay, yes. So I assume this is maybe minus 3.65. Okay, I'll just mark a C over here. Right, so that's the centroid. Now at the centroid, all the four asymptotes will meet. We expect four asymptotes because the number of branches going to infinity equal to number of asymptotes. So there are four branches going to infinity, so I need four asymptotes. So when I say I need to draw four asymptotes, I need to find four angles corresponding to them. This is angles of asymptote theta is equal to, this is odd multiple, so 2q plus 1 into 180 whole divided by the poles minus 0. So many branches I'm expecting. So this q actually starts from 0, 1, 2 and so on. You need to substitute so many values to q, right? As many number of branches you expect. I expect 4 branches, so 0, 1, 2, 3 is what I'm expecting, right? So we'll calculate. I just write comma 3 so that we are sure that we substitute only the four values. So you can call this as theta q itself. So theta naught is equal to, put q is 0, right? So it is simply 180 divided by 4. Okay. 135. We got four angles. Now we just have to measure it and we have to plot. Okay, so first, all right. Okay, okay, I'll explain that. So this is 1.63 s squared. Okay, 019s. Okay, so everything is negative. We can expand that. So this is equal to minus s to the 4 minus 13.08 s cube s. So that's right. Now I have to perform the dk by ds. Differentiate this with respect to s. So anyway, minus can be kept outside. So this is 4 times s cube. Okay, then plus, so 13.08 into 3 s squared. Yeah, please write that equation and then tell me that. 39 s square. Okay, 103.2 s plus 26 s plus 40,019. Now this, as per the first equation which we can see here, I have to equate this dk by ds to be 0, right? This implies the, anyway, the minus sign will cancel now automatically. So I have to equate, correct. So that is correct. 4s cube plus 39.24 s squared plus 103.26s plus 48.019 equal to 0, and we have to find out the s values. Correct. Perfect. Perfect. Okay, the first one is minus 0.589. Okay, 3.676. And yes, correct, correct. So directly we can minus 0.5. Now have to choose the middle ones. Like, see, 0.589 minus 0.589 lies here, right? Here, over here, correct? So this point, I want to consider somewhere in the midpoint. Okay, this is minus 0.589. So the next one should be right between minus 3 and minus 9. You have to choose the appropriate one. So there is minus 3.6 and minus 5.45. So minus 5 point, the midpoint, right? So minus 5.5 you will choose. So somewhere here, minus 5 point, how much? 5.5. That's 5.5. 5.54, I'll write. Okay, so these are the two breakaway points. So from here you have branches coming out. Okay, right. So again, no more details are required for the ones, for the two branches I'm writing over here. So they will just come out and they will go to infinity with the help of these two lines. Okay, so infinity. Same thing will happen at the bottom, right? It will, these branches will directly go to infinity with the help of these two. Similarly, I will draw two more branches, but I need more details about that. Okay, so that is where the branches are going to cut the y-axis is your next detail, right? So this point I have to find out. Yeah, correct. So similarly, it comes like this and it will go like this. So where is the intersection happening? I need to find out. Okay. Yeah. Yeah, yeah, yeah. Sure, sure. Please take your time. Then we'll continue. Okay. Now, so to find the what do you call the intersection, right? We have to apply the RH criterion. Okay, because we have seen that where the exact points where the system is marginally stable, that point itself corresponds to the intersection. So what we have to write the characteristic equation, right? The 1 plus gh equal to 0. Already we have done that. I think you can directly write that part. So 1 plus the k over s plus 1.5 into s plus 3.25 and s plus 9.85 equals to 0, right? Don't take the terms to other side, keep it on the same side. So something plus k equal to 0 is what we write. So I think we can write it from the above equation, right? So this implies now s to the 4, we can directly write this, right? S to the 4 plus 13.08 s cube plus 51.63 s square plus 48.019 s plus k equal to 0, because k is equal to negative of this. That's what we wrote, right? So I bring everything to the left side to get this. The denominator anyway it will go to the other side and gets multiplied with 0, so it is 0. So we got the equation right away, right? We have to use this, and we need to calculate the range of k first, for which the system is stable, right? Okay, so to solve that, what we do, we directly go for the RH. S to the 4 s cube s square s to the 1 and s to the 0. Okay, okay, please tell me the values. Hmm, hmm. uh, okay, can you repeat? 2302.99 minus 8k. Okay, then It should be K, right? Okay. So from this row, what's your conclusion? K should be positive. Right. So from this, the second row, we can you will get something K less than something, right? Yeah. So it's like 2302.99 divided by 13.08. That number, whatever you get, K should be less than that. 76.07. So the for stability, this is the condition: 0 less than K less than 176. The marginal value is 176. So again, I'll go back and I'll check how many roots I require, right? How many points are there on the y-axis? Only two. If at all you see four different points, right? Let's say there is another branch coming like this, means maybe I expect two more, correct? Two more points. So that case I should go for the fourth order equation, right? But a square term, right? So I'll write the equation, right? You call it as a auxiliary equation becomes now. This is 47.96 s square plus that k value. K is 176.07 equals to 0. So, so that means you need to find two values of s now. So s is equal to, right, there is minus 176.07 divided by, so s square is equal to divided by 47.96. Minus 3.67. So s is equal to, there is a minus, so this is, anyway, root means it is plus or minus. There is a negative, so j, right, root of 3.67. You have plus or minus j 1.91. So this means, right, it's going to intersect j91 is this point. This is minus j 1.9. So for this particular problem, we don't need any other details, right? And for some other cases, you may require to find few more details as well. Okay, right. So these are the steps to be followed to plot the root locus. Now this particular plot is the root locus of the given problem.